So I have 4 equations here, and supposedly when I graph these lines, they intersect to form a rhombus. So let's figure this out. Let's graph them first. So let's start with x equals 3. That's just a vertical line at the point 3, or at x equals 3. So let's see. So that's right here. Okay, there we go. This is x equals 3. And x equals 0. That's just the y-axis. So I'll put x equals 0. And now I've got this line 3y plus 4x equals 12. Well, let's use our intercepts. 3 times 0 plus 4x equals 12. That cancels out. Divide by 4 on each side, and x equals 3. So this line crosses at x equals 3. And 3x plus, replace the y with a 0, equals 12. That goes away, and divide by 3 on each side, and this would be a y, sorry. And we get y equals 4. So just replace the x with a 0 to find replace the y with a 0 to get the x-intercept. Replace the x with a 0 to get the y-intercept. And we get 1, 2, 3, 4. So that line crosses here. I wish I had my ruler, but here we go. And this is 3y plus 4x equals 12. This next one, 3y plus 4x equals negative 3. I'm not going to use the intercepts method because let's see up here, if I take away the y term, 12 is divisible by 4, so that works. If I take away the x term, 12 is divisible by 3, so that works. Here, this isn't going to work, right? So that's going to give me a fraction. I can't really graph a fraction easily, so I'm not going to do that. We're instead going to solve for y. So we'll say 3y plus 4x equals negative 3. Take 4x away from each side. 3y equals negative 3 minus 4x. Divide everything by 3, and I get a negative 1 minus 4/3 x, which I could rearrange as negative 4/3 x minus 1. So that's my slope. And that's my y-intercept. So y-intercept of negative 1 and the slope of negative 4/3, which means we go down 1, 2, 3, 4, and over 1, 2, 3. Right there. So there is let's label this one, 3y plus 4x equals negative 3. So there is our shape. And we can tell, we're trying to decide if it's a rhombus or not. A rhombus has 4 sides, they're all the same length. So let's see, this one is 1, 2, 3, 4, 5. Right, up here we have 1, 2, 3, 4, 5. So far so good. And here we have 1, 2, 3, 1, 2, 3, 4, and that's that 3, 4, 5 triangle. Or we could use Pythagorean theorem to show that, but by now we just kind of recognize it. And here, 3, 1, 2, 3, 4, 4, 5. So it's a rhombus. All 4 sides are the same length. We could have also done, we could also found the points of intersection using algebra if we didn't have the drawing. And then we could have used the distance formula to find the distance between them, but I mean, since we have the picture, why go to all that bother? It's a rhombus.